put together what we've learned about voltaic cells. So we're going to start with what our reaction involves. So we are having silver being reduced and lead, since it is reducing the silver, it itself is being oxidized. Okay, and then we're going to assume it's oxidized to lead 2 and not lead 4. Okay. So for the reaction for oxidation, I'm going to start with the lead, that's the solid, and I'm going to oxidize it to lead 2. And then I'm going to balance that, figure out my electrons. The electrons always go on the more positive side, so I need 2 electrons here to have that make sense. And again, oxidation takes place at the anode, so I'm just going to note that here. Next, what's reduced is the silver ion. And of course it's going to go to the solid. And I left room because I know my electrons need to go on the side with the positive one, and in this case it's just the 1. Okay, so those are my half reactions. To get the overall reaction, I have to balance those with each other. Label this. In other words, I need to make sure that the number of electrons being transferred is the same. And here, lead is giving up 2, and the silver is only accepting 1. So to balance the 2 with the electrons, I need to multiply this one times 2. So my overall cell reaction and again, what I did when I balanced this to get 2 electrons, then the electrons don't appear in the net, the overall, because they cancel. Okay, but this 2 ended up causing this 2 and this 2. Next, we're going to draw the voltaic cell for each half cell and label everything. When you do this, keep track. Your anode needs to be on the left and the cathode needs to be on the right. So that means when you draw your metals in there, you need to have your lead over here because it was at the anode, we said, and the silver will be over here because we said that was at the cathode. Each solution has the corresponding ion. We can have a voltmeter between the two. Electrons always travel from the anode to the cathode. And that makes sense if we look at our reaction. Lead is giving up electrons to become +2. It wants us to have label the terminals. Let's put the charges, or we label the anode with a negative and the cathode with a positive. I need to show my salt bridge. And just to make sure we're clear, these pieces of metal are the terminals. This whole thing is an electrode, and this is or a half cell. The whole thing together, both sides, is a cell. Now let's look at how to do the line notation for this cell. You still do, remember the anode is on the left and the cathode is on the right. And then you start with the terminal. I know that I'm going to have lead on this side just like I did there. I'm going to have my solid terminal, and I could put a number over it, then a line for a phase barrier, and then the ion. And then if you look right here, you know, the way that I put these, of course the solid is on this end, but this is how the reaction occurs from left to right. If we look at that half reaction up here, that's the order that they go in here. We need to say aqueous there. And then the salt bridge. And again, on this side, this is the order of this half reaction. It goes from the ion to the solid silver, which is something I didn't show up here, is that here we have the lead kind of dissolving, and here we have the silver plating out.